Hello class! Today we are going to cover the real numbers standard on simplifying square roots of non-perfect square numbers. This relates back to your knowledge of working with perfect squares and will also have application to our previous lesson on the Pythagorean theorem. You already know how to find the square root of perfect squares like 4, 36, 81, and more, but today we will work on numbers like 12, 32, and others that do not fit on the perfect squares list. Previously, you have likely been asked to round these numbers to so many decimal places, but today we will learn how to keep our answers exact and not use decimals at all. It will be helpful to recall how to find perfect squares and even utilize the perfect squares list I shared with you previously in our course Google Drive and on our course website. If you remember to find a perfect square, all you have to do is multiply a number by itself and you have one. For example, 8 multiplied by itself is 64. So 64 is a perfect square. So how do we approach a number that is not on the perfect squares list, like say 12? Well, first you will need to find a perfect square that divides into 12 evenly. So let's say 4. 4 is the perfect square on our list, it's 2 multiplied by itself, and 4 divides into 12 evenly 3 times. So we can rewrite the square root of 12 as the square root of 4 multiplied by the square root of 3. Get into the habit of writing your perfect square first, as our final answer format will place the perfect square answer in the front, in first. So, we know what the perfect square of 4 is. It is 2. There is no perfect square of 3, so it will simply remain in the radical sign. Now remember, the radical sign is what many of you referred to as the square root sign until we discussed that there were other roots beyond just square roots, and it looks like this. So that's it. Our answer is 2 square root of 3. Now, the only trick to this is trying to find the largest square root that will go into your non-square root number. If you don't succeed in finding the largest, you will have to do these steps again in the same problem. For example, let's try simplifying the square root of 72. Due to basic multiplication, you want to jump to rewriting 72 as the square root of 9 multiplied by the square root of 8. 9 is a perfect square, and indeed, 9 multiplied by 8 is equal to 72. But wait a minute though, and think about this. Is there a perfect square that goes into 8? Can't 8 be broken down more? Well, yes, it can, by using the perfect square of 4. 4 is a perfect square, and 4 multiplied by 2 is equal to 8. This tells us that using 9 multiplied by 8 means we did not choose the largest perfect square. So what do we do now? Well, I'm going to show you 2 ways to approach this problem. The first is to simply work with 9 multiplied by 8 that you thought of first. In this case, we would rewrite 72 as the square root of 9 multiplied by the square root of 8. Writing 9 first because the perfect square goes first. We know the square root of 9 is 3, and 8 does not work out evenly, so it remains underneath the radical sign. At this point, we would stop and check to make sure no more perfect squares will go into 8 and that we have actually simplified everything. At this point, you would find that 4 multiplied by 2 is equal to 8 and repeat the process. So we have our 3, the square root of 4 multiplied by the square root of 2. The square root of 4 gives us 2, and the square root of the other 2 will not break down any further, so it remains underneath the radical sign. All that is left for us to do is multiply our integers together that are in front. We are dealing with multiplication throughout the whole process, so putting the 3 and the 2 together that were pulled out in front gives us 6 square root of 2, our final answer. So what would I do to avoid having to simplify and repeat the process again for the second time in this problem? Again, finding the largest perfect square that goes into 72 to begin with will help us avoid this extra work and the extra room for making mistakes. Once you find 9 works, try some more perfect squares from our list. 16 is the next perfect square. It doesn't go into 72 evenly. So how about 36? Well, that's the one. 36 multiplied by 2 is equal to 72. And we know that 2 won't break down any further with perfect squares. This is the indicator that we have found the largest perfect square that goes into 72 when we use 36, because the 2 will not break down any further like the 8 would before. So, rewrite 72 as the square root of 36 multiplied by the square root of 2. The perfect square of 36 is 6, and the 2 remains underneath the radical as it can't be broken down any further. You can see this gives us the answer of 6 square root of 2, just as our previous method did. This way just saves us a little work and again takes away some of the room for errors in our work. So for one last example, let's apply this to our work with the Pythagorean theorem. Take this right triangle, for instance. We can see that we are given one leg measure of 4 and a hypotenuse measure of 10. Applying the Pythagorean theorem as we have done before, we will have 4 squared plus b squared is equal to 10 squared. So 16 plus b squared is equal to 100. Subtract the 16 from the 100 as we've done before, and we see that b squared is equal to 84. So to actually solve for b, we take the square root of both sides, and we'll see that b is equal to the square root of 84. Now, your directions will tell you to simplify your answers and to not give decimal approximations. So this indicates we should simplify the square root of 84, which is not on our perfect squares list, as there is no number multiplied by itself that gives us 84. So what perfect square will go into 84? 4 is our smallest perfect square that we use to simplify with, and 4 does in fact go into 84 21 times. Now think for a second on the number 21. Are there any perfect squares that go into 21? You can go through your list fairly quickly and see that 4, 9, and 16 do not divide into 21 evenly, and 25, the next perfect square on the list, would be too large. This tells us that 4 gives us the largest perfect square. So rewrite 84 as the square root of 4 multiplied by the square root of 21. We know that the square root of 4 is 2, and that 21 cannot break down any further and is not also a perfect square. So our final answer is 2 square root of 21. So that's it, guys. That's all the tips and tricks to simplifying non-perfect square roots. You have been emailed 3 exit questions for this lesson. Please open the form and answer those questions now. Let me know if you need any help, and I'll see you guys next time. Thanks for a great lesson.